Hello and welcome. I'm Jim Kaufman with Rankin Technical College. Today's video is going to be about an introduction to React. Also, we'll talk about Vite a little bit. We'll go ahead and create a quick little application, React app using Vite. And I kind of want to go through some of the Vite stuff as well. So let's go ahead and get started on this. So React has pretty much transformed modern web development. It was developed Facebook back in 2013 and introduced a component-based architecture and a virtual DOM. So as far as a component-based architecture, it's actually things are written in small job. It was originally that used to use class components. Now with later versions, use what's called functional components, but they're just basically little small, pieces of code, right? Little small components that you can use, and a component can be a button, can be, it could be a whole page, it could be a button, it could be a section on a page. So a component can be, quite big or it could be quite small, and also components can be made up of other components as well. Okay. And also the virtual DOM. What the virtual DOM really is it's actually a copy of the document object model from within the browser. It's a copy of that. It's called the virtual DOM. Where with React, you'll under the hood, you don't have to worry about it as a developer. This virtual DOM will be updated as you make changes to things. Okay. And then this virtual DOM will update the regular DOM. And the whole purpose of this is because it's very time consuming, and the word expensive, it's called kind of expensive to constantly be redoing the DOM. It's very slow, that DOM. It recreates that whole DOM each time. And for simple pages, you're not really going to see it, but from a computer standpoint, it's slow. Okay, and especially you have a very complex page, it's going to be very slow. So by doing a virtual DOM, you can make certain little small, when you're making updates, it's going to just make some updates to that virtual DOM, and then it's going to find the most opportune time to go ahead and update the regular DOM. Okay, it's just a certain technique that was designed for the React, and it's really has really helped simplify it and make it much more performant. So let's go ahead. Also React has a declarative approach. We'll talk about that in a little bit. And it has an extensive ecosystem that has made it a cornerstone of modern web development. So the objectives of this lecture, we're going to just talk about the evolution of a React, differentiate React from traditional DOM manipulation, kind of what I was just really talking about a little bit, explain the React paradigm, identify React as single page applications framework, implement and manage state in React, recognize the pros and cons of single page applications, and go ahead and look at this React Learn website. This is the react.dev. This is the official React documentation and website. And we're going to also, I'm going to grab a couple components from there. So we're going to create a quick React app using Vite, and we'll drop a couple components in there as well. So like I said, it originated back in Facebook. Its core concepts is that whole virtual DOM, where you use that virtual DOM that gets updated, and then it finds the opportune time to update the regular DOM within the browser, and it's very performant the way it does that. Okay. And we're going to talk a little bit about the evolution and impact here as well. Okay. So it was created to address challenges in building large-scale applications at Facebook. Okay. Facebook released React as an open source project. aiming to improve performance and simplify UI development for the wider community. Just a note, initially was met with skepticism, but React gradually gained popularity. Probably a lot of skepticism because it's a little different, especially when it was doing that whole DOM stuff, and people probably question, well, you're creating a copy of the DOM. You would think that it would be slower, but actually the way that it's implemented, it's actually a lot faster. But it, gradually gained popularity due to its innovative approach and ability to enhance code maintainability. So React's core paradigm, key concepts that define React's approach to web development. It's all about components. Okay, when you think React, think components. It's component-based architecture, front-end composed of reusable, custom-built components for simplified maintenance. And always remember, React is always front-end. So in this course, we're doing a full stack where we're using Express and Node on the back end, right? And so we're using other technologies, for the full stack, but React is just, a front end architecture, okay, a front end library. I already talked about the virtual DOM. It's efficient UI updates through diffing between the virtual DOM and the real DOM. Declarative approach. So it describes desired UI state, contrasting it with imperative DOM. I think I have this up here. So here's some difference between declarative and imperative as far as from a programming standpoint. Declarative languages, declarative libraries, frameworks, the whole concept of declarative as opposed to imperative. Declarative, you kind of just you ask what you want, what do you do, right? Well, imperative, it's how do you do it. So it's much more intricate on the imperative side. So like examples of declarative is SQL, HTML, React is more on the declarative side. It's kind of you ask for what you want as opposed to when you're doing a programming language, C, JavaScript, C# can be included, traditional JavaScript, etc. You have to do each intricate. You have to do a loop. You have to control every little thing, right? You're in control of all of it, right? Whereas from a declarative standpoint, you kind of pass a little bit of control over to the framework or the library or the programming there. HTML is basically a declarative language, if you kind of recall the definition of HTML. As far as abstraction is concerned, so basically when we use the word abstraction, a simple way to kind of think about that is in coding, abstraction means that higher level code relies on lower level details being handled by something else, okay? So in the case of SQL, HTML, React, something else is taking care of some of the lower level details, right? Whereas when you're using, and not that some programming language also have parts of declarative, right? But at the root of the basically programming languages, you're creating variables, you're updating variables, you're writing loops, you're controlling all of that, right? So the abstraction level is lower, okay? It's about simplifying. Abstraction is about simplifying how we interact with systems by focusing on essential functionality and concealing the intricate inner workings, okay? Readability. So as far as declarative is generally more readable. Imperative, it's a little bit more, it's a little less readable. It's a little more complex. Control, you have less control over execution. You just say, hey, I want this. And the library, the framework, whatever you're using is going to go ahead and just do that, right? Whereas for imperative, you have more control over the execution of things. Okay. So in essence, declarative programming is giving someone a recipe. You describe the final dish without telling them how to cook it. Where imperative is like giving someone a set of instructions. You tell them each step of the cooking process. Okay. Just kind of want to go through that. It's a declarative, imperative. It's kind of important in your career to kind of understand the differences. It could be an interview question, and it's very important in just coding and understand how you're doing things. Also, with React, we have this what's called JSX, and this is a syntax extension resembling HTML that allows embedding JavaScript. Functional components and hooks. So originally, React was class components. And think of, everybody that's in this course, you've already taken C#. You remember having to write a new class, you extend the old class. You had to do a lot of things there. Whereas with functional components in React, they're just basic JavaScript, small little pieces of JavaScript. Okay, you don't have to write, used to, in React, you used to have to set it up a certain way, say certain, have certain words in there and everything else for it to work correctly. You had to use certain libraries that were available in React so everything worked. Whereas now with functional components, you just basically have a basic JavaScript function and you say export it and that's it, right? And then single page application, which is all called SPAs, delivers HTML, CSS, JavaScript as a single page application for improved user performance. So evolution of React, from classes to function, and that's what I was already talking about. So originally, class components were the initial standard. Use these class components, and then in 2019 they transitioned to functional components, just basically for simplicity. And they also introduced what's called hooks. Okay, and hooks introduction revolutionized state management. We'll look into that a little bit more here. Continuous improvement, introduction of hooks in 2019. The two most popular ones is use state and use effect. Okay. Regular updates enhancing performance and features, and strong community contributions driving innovation. React. So React versus a traditional DOM manipulation. React's approach is the declarative programming paradigm, where we're passing control to the JavaScript, the React library to take care of some of them lower level tasks, right? Virtual DOM for efficient updates, or component-based architecture for modularity. JSX for intuitive UI description, and simplified state management with hooks. Traditional DOM manipulation, that's more imperative. We all in our HTML course that everybody's already been through, that's in this course. Remember when we had to update the DOM, we had to go in there and specifically update the DOM, and that's the more imperative approach, right? Direct manipulation of the real DOM, script-based approach for UI updates. Separate HTML, CSS, and JavaScript, complex state management across elements. Okay, React component-based architecture, modular and reusable. The good thing about a component, you can create a component and it can be used in you may have a component that's a parent component and it has multiple child components. And so that child component could be used in other components as well, right? So it's reusable. So you break down complex UIs into smaller pieces. So a component can be a button. A component could be a list on a page. It could be like the footer, the header, the navigation, and even with the navigation, you could have multiple components within the navigation, right? So you kind of break down, something that's monolithic into something that's more manageable. So it simplifies maintenance and reduces bugs, enhances code reusability across projects. Then also there's the JSX syntax. It's an HTML-like syntax extension for JavaScript. It allows embedding of JavaScript expressions and transpiled into browser-compatible JavaScript. So later when we talk about Vite will take care of taking that JSX code because a browser don't know what JSX is, right? So that's where when we use that build tool called Vite, that's where that comes into play because it'll actually take that and it'll transform that into regular HTML and JavaScript. Okay. ES modules in React import and export components efficiently. Organizes code into separate files and facilitates better code management and reuse. Okay, React as a single page application. So single load, browser loads one HTML file and JavaScript during initial load. So just to kind of back up a little bit from this, basically React is primarily designed not so much for building websites. In the HTML course we did, website development. But React is really designed for building dynamic web applications rather than simple static websites. While it can be used in websites, its strengths lie in creating interactive and complex user interfaces. Okay, so and then a single page application. React is commonly used and it's well suited for building single page applications. React component based architecture and its efficient rendering makes it a popular choice for creating dynamic and interactive user interfaces, okay, with single page applications. So you've got, single load, you have dynamic rendering. So React will update just certain parts of the page without reloading the whole page. When we did the static stuff, you made a change. Yeah, obviously we did use that live server and stuff and kind of updated some stuff automatic. It refreshed the page is what it did, okay? But so we're not talking about refreshing the page. We're not talking about in a development environment. We're talking about an app that actually is running, within the browser. So React is basically a front-end app running in that browser. So you can actually make some changes. You could do certain things. You could push a button and it might update a small piece on that page, but all the rest of that page didn't update at all. And that's all through that whole DOM manipulation stuff, okay? It's just updating certain parts that needs to be updated. Client-side routing. React Router enables navigation without a page refresh. Faster navigation, only necessary parts of the DOM are updated. App-like experience, interactions feel smooth and immediate. Reduce server load, front end handles most updates after initial load. So React being a kind of a front end type of library and tool, it takes a lot of that off the back end. Back in the day, and it's still to this point you can still build web applications in obviously other ways. But originally building a web application, if you had to do anything sophisticated besides just the basic HTML stuff, you would basically click a button, it would make a call to the back end, it would do something, it would return the response. Whereas here, you can actually, in a lot of cases, do some things just in the front end without having to make back end calls, right? That's that. Okay. Benefits of single page applications, faster navigation, updates necessary DOM parts, app-like experience, smooth and immediate, reduce server load, front end handles most updates. Technical advantages, dynamic rendering, JavaScript updates without reloading. Client-side routing, navigation without page refresh. So you can basically, even though you may not be able to view everything, on a React front end, you could have a single page application that does have maybe other pages still, but it doesn't go make calls. It hides something, shows something else. So you could click something where it's actually, you think you're going through multiple pages, and from a visual standpoint you are, but it's actually just really considered one single page application. It's all loaded within that DOM. Improved performance, efficient DOM manipulation. We kind of talk about that over and over here. So some challenges for single page applications. So SEO, remember search engine optimization. Search engine optimization is obviously very important for websites. And, also, for web applications as well. So that's one thing is, sometimes, it depends on what your needs are. Obviously, if you're building an application for some internal thing, you're not, some internal thing at your company, you're not really worried about SEO. SEO is more for a marketing standpoint. You're trying to get a public to your site. You're trying to get people to your website, right? So when you're trying to get people to your website, SEO is very important. When you're just building a web app for your own company or something internally, SEO is not important, right? But, sometimes you're going to build a web app that you also, are making that available to the public too. So when you do something like that, SEO is kind of important, okay? But so there's challenges with that, Dynamic content is difficult for search engines to index. So having them single page apps, how it loads everything in that DOM, it's not good for search engines to index because search engines basically flip through all those pages. They have little robots. Search engines like Google and that, they have little robots that flip through all the internet all the time and index those pages, right? But when you've got dynamic content that gets loaded in the DOM, it's difficult for them to do that, okay? So bots struggle with JavaScript rendering pages, and server-side rendering can help mitigate issues. Yeah. And that's, server side basically for SEO related. So initial load time. So one thing about a single page application, it's going to be a slower load time. You're bringing a whole bunch of stuff all in at once. So you have slower initial load due to upfront asset loading. Large JavaScript bundles impact user experience. And it's particularly noticeable on slower networks or devices. Okay, memory usage, potential for higher memory consumption. So that when, I'm sure you've, had a browser running and all of a sudden your fan kicks on, you can tell that, it's using a lot of resources and that. Maybe some things slow down. So, when your React apps can use they will use a little bit more memory in that, and so it'll a little bit more memory on your computer is necessary, right? Long-running applications may experience memory leaks. Requires careful management of component life cycles. All right, state management. Trying to see what we really want to go here on this. Yeah, I think that's on here. I just want to go through a few more things here, though. Just to kind of more of a review here, So basically, React's a JavaScript library for building user interfaces. Think of it as a set of tools that help you create interactive and dynamic parts of a website or app. And one thing I did want to kind of mention, and did I have anything? Why is React? Why is React a library? It's a library rather than a framework. So And the reason it's considered a library is because it focuses on specific tasks, UI rendering, and it offers flexibility in how developers structure their application rather than imposing a rigid structure like framework. Okay. So, um, so here's frameworks versus libraries. So frameworks actually dictate the overall structure and flow of your application. They provide predefined architecture and often handle many aspects of the development like routing, state management, and data fetching. So you with a framework, it's going to take care of a lot more, but you have to follow everything precisely, right? So some examples of front end frameworks is Angular and Vue. So Angular is they're both similar. They have similarities and differences from React, and it's kind of might be especially Angular probably be a good idea to at least know what those are, both Angular and Vue, but especially Angular's kind of used more on the enterprise side of things and more within like large organizations and companies use Angular. Libraries offer reusable pieces of code for developers to use. They don't impose a specific structure and allow developers to choose their libraries and tools. Okay, so you can do a lot of things, and even with a React app, you can have a regular website and just have a little piece of it that actually is using React. Right, so it's not like you have to have everything has to be React. Right. You can kind of mix and match if needed, right? All right, just kind of want to mention that one there. And this just kind of a review what we actually went over, plus a few other things. The components, a self-contained, reusable piece of UI. So imagine building Legos. Each Lego brick is a component. You could combine them to build bigger things. Examples: a button, a navigation bar, a whole page. Right? Your component could be a whole page. It's probably not smart. I mean, it's probably not shouldn't say smart. Probably not the best way to do it, but a whole page could be a component, and then I shouldn't say that. I shouldn't say that. You shouldn't have it just be your only component. Your page could be one component that's made up of a bunch of other components, right? So it can be a whole page. And then also JSX, remember, is JavaScript for XML. An extension for JavaScript looks a lot like HTML. Lets you write UI code that feels familiar, even though it's actually JavaScript. React then understands how to turn them into actual web elements. Something else that we didn't touch upon in the presentation is props. Props is a way to pass data from a parent component to a child component. Think of it as giving instructions or ingredients to your Lego brick, right? Props are read-only. Very important to remember, props are read-only, meaning that child components can't change them. And always remember that props flow from parent to child. They don't flow from child to parent. Okay. The idea of state. So I do want to mention here a little bit about state. So data that a component can manage and change itself. If a component needs to remember something, so state is really something that's kind of remembered by the component, okay? So if a component needs to remember something and potentially update its display based on that memory, like a counter that increments, it uses state, okay? When state changes, React automatically re-renders the component, okay? So there's a certain way you do have to in React so that React knows that you change the state. You'll have to use these set state type functions so that it knows, oh, this changed, and it will go ahead and update that in the most efficient at the proper time, right? It will do it in the most efficient way necessary. What else I want to say about state? So a little bit more. State refers to a JavaScript object that holds data or information about a component that can change over time. It's a component specific memory that allows a component to remember information between the different renders, right? So it's like your page rendered or that component rendered, and then all of a sudden you're making some changes in your code. I mean, well, not I don't want to say making some changes in your code, but your component, you're maybe doing some things, you're pushing some buttons, you're entering fields in the text box, and all of a sudden that component's changing, right? The component's changing. It hasn't been rendered yet, but the component's changing, and until that renders again, it's using that state. And then once it renders, boom, it pretty much flushes that state and kind of starts again, so to speak. The virtual DOM, we talked about that quite a bit. Render, remember render is the process of displaying a component on the screen. When a component's props or state change, React re-renders it to show the updated information. Also this idea of hook. Now hooks are special functions that let you hook into React features, like state. State is a state can be managed using hooks, and also there's lifecycle methods. So a lifecycle method is like basically the way a component is from a conceptual standpoint is mounted. It's a mounted, it rendered, and then it can be unmounted. Because you may do some different things where you change things, something disappears, something gets replaced with something else, and so that component could be be outside the memory. It could be actually unmounted within your page, right? It all depends on how you handle things. But common components include use state for managing state and use effect for side effects. And it's important to, I think, use state and kind of understand what that means a little bit. You're just kind of holding on to information. Whereas use state, I can, that's, well, what is side effects? What's that really mean? It's just kind of a fancy way to say, side effects are operations that interact with the outside world or affect things outside the component's rendering cycle. Okay. So like if you're making a call to an outside API, you're bringing in some data, you're, doing something that's out, but, basically it's anything that's outside of your component is basically a side effect, and you would use effect to do that. Okay, it could be use effect to get some data from a database, to call an API, many other things as well. Okay, and then we're called side effects. Functional components. This is how you do things. Class components will still work within React. But functional components is in a new way. When I say new, 2019. Obviously, it takes time for, people to, adopt things, right? It's not usually quick adopters. I guarantee there's a lot of code out there at companies that are still using class components, right? So, always keep that in mind. You might go into somewhere to work and they're actually using class components still. So a functional component is defined as JavaScript function with hooks, and these are now the preferred way. The class component's an older way to define components, while still supported. Functional components with hooks are generally favored for their simplicity and readability. Lifecycle methods, especially methods in class components that run. Lifecycle methods are very important. You had to do a little bit more when you had to write class components. You had to handle all the lifecycle stuff a lot more. When a component's mounted, when it's unmounted, and all that. Whereas now it's kind of taken care of behind the scenes a lot more. It makes it a lot easier. So, but nowadays hooks use effect to provide similar functionality for functional components. we're going to skip that for now. Single page application, a web app. Okay, we already talked about that quite a bit. All right. So that's that. Let me think if there's anything else. No, I think we're good there. So what I want to do now, so I'm just going to go, go ahead and create using Vite, just create an app. We've done this before, but I'm going to kind of go through this a little bit, talk about a few other things as well. A little bit more in depth than maybe what we've done. I know in the HTML course, we did a little bit of React stuff, not a lot, it was pretty much, do this, do that kind of instructions. So I want to kind of go into Vite a little bit more, explain just some things so you kind of understand what that is and what that's about. So I'm gonna open up this lecture one to create this app, I think. So let's go ahead and bring that into Visual Studio Code. I don't know why that did that. I don't want all of that. I guess I didn't select that, did it? That's a little weird. All right. So basically, you're just going to come in here and go to a new terminal. And then the basic function, right, for creating. Now there is an old way to do this. Vite's not the only way to do this, but it's kind of really become very popular, and I suggest you don't try to use other tools to do this. I think it'd be best just to use Vite, especially for this course. But npm create Vite latest. And so it's asking for so I'm just going to create my app and then choose the stuff here, which we're doing a React app. So obviously Vite, you can do Vue there. There's other ones as well, right? Lots of different other libraries and frameworks, front end, but React is the most popular of these and the most widely used, probably the most jobs in the area as well. So it's probably the best one to know. And we're going to go ahead and do JavaScript. So always remember to make sure you CD to it first, so it creates everything in the right place. And then I'm going to do npm install. Which is very fast. I remember not that long ago, it'd take a while. You had to kind of left and come, go make some coffee, pour yourself coffee, get something to eat for a minute. That's a lot faster now. So I did kind of just want to go through a little bit what Vite created here. And, just kind of review that, basically Vite's a build tool. Let me see if I had any other notes on Vite. I thought I did. Maybe I'm not sure where I put those. But Vite's basically a build tool. It helps to build React. It could be other libraries or frameworks as well, but it helps to make things much simpler, right? You used to have to do all this stuff yourself, which Vite kind of takes care of a lot of this, right? So it kind of explodes this out into a certain structure, okay? And then obviously you got my app being your, this is your project's root directory, and it contains all the files and folders. Obviously, we're all familiar with node modules, and here, after that one, you've got the public here. And so what public is for Vite. This is for things that kind of you need at the root level of your application, being it a favicon, some kind of some kind of images, not necessarily something specific to a component at all, right? Something that's kind of relative to the root of your application, okay? Here it has this little Vite image, right? So this is a place you would put something like a favicon or something that's necessary for that's needed at the root of your application and not like within a component or anything, right? Let's see. So basically, source is where you're going to kind of be doing most of all your work, right? This is where all your code's going to be, okay? Now, source, I know we've done some different things within this, this course and even other courses on structure. But, a lot of times, especially my experience in development, usually every place I worked, we had source directories. Usually the source was your the name of your root directory was always source. And then from there, you could have other directories as well, but source was usually always the root directory. Not that hasn't changed a little bit within time, but it's still very common. And obviously, Vite uses source as that root directory of basically your source code, right? Now, assets. So here's an asset. So this asset here. So this folder typically is used for assets that are. It's actually Vite takes care of it, and what it will do with these, it will optimize these and cache them to include it in your build. It does special things. So these are things that you may be using on multiple pages. It might just not be on one page. It may be maybe within a component. You're using it in multiple places. It's something that could be used a lot and. So what will happen is it'll actually cache those. So it's good for images, icons, fonts, and different things like that. Okay. Let's see. What else I want to go through? Let's hold off on that, I think. Let's hold off on that. So let's go down to git ignore. Just kind of wanted to go through this again. So git ignore, basically what this does is when you check in code. I know some of you have used it, some of you haven't, and just kind of want to review it. So basically this is making sure that by git ignore is anything that's in your directory here will not be checked in code, right? It will not get checked in, okay? So this is a whole list of things. And just to kind of recall, is basically depends on the location of things. So when you've got this in the root, so this is all root stuff, right? This is root level. So if you've got this in the root, it's basically going to take effect here, and it's going to be in all your subdirectories as well, right? It's called recursive, right? Root all the way down. So it's going to reflect everything in this git ignore, right, is going to reflect everything in all these subdirectories as well. So if any of these files that are in git ignore that are stated on git ignore are in these subdirectories, it will not check these in, okay? And a lot of times you really don't want to do that, right? Because especially when you start getting bigger apps, that's a lot of code. That's a lot of stuff. You can have a lot of node modules. The dist directory can be very big, okay? And I'll show you. I think pretty much everybody in this course pretty much has done the dist directory already, but we're going to kind of review that a little bit here. But that's basically git ignore. The ESLint stuff, just so you know what that is. So the purpose of this configuration, it's a popular, it analyzes your code for potential errors, stylus use, best practices. Just kind of some built-in functionality, okay? And you can actually change things. You can configure rules. There's plugins. There's all kinds of things you can do. that we're really not going to do. But you can make it specific for your organization. Say, within our, even your team. Say on our team, this is how we style our code. This is you can, these are our best practices, and you can define things like in here that's going to show you a little warning sign when it doesn't meet the qualifications that you have configured in here. Okay, that's what this ESLint stuff can do. Okay. Your index.html file. Now, for a Vite app, for a Vite app, for a React app, I should say, for a React, using Vite as a tool, it's going to be a pretty lean, small file. There's some things that for like the final project, we're going to be adding some things, but it's not going to be extensive. This file may end up being like 20 lines. Okay, there's just some things that we could define here that could be used by all the other files. Okay, but so this will not be extensive here. Okay, this will be a pretty lean one. Like I said, maybe 20 something lines at the most. Okay. Did want to go through this here. So we're all familiar with the package JSON file, right? And, so like this file here, you can know it's about 28 lines. Obviously, extra space in there. That's fine. This will have your dependencies. You can have both dev dependencies. So these dev dependencies are related to development, right? So this is all used for development purposes. And these are dependencies that are going to be needed for production, right? And these got to kind of get put in there based on when we do the npm installs and so forth, right? Then obviously we have scripts and others, but this is just kind of the base file that we use here, right? But the package.lock, if you look at this file, I don't know if you ever have. Look how long this one is. This is like 2,800 lines. Okay, and the purpose of this file is. It's automatically generated from NPM, just like the other one, but it records the exact version of every package installed in Node modules, including all the dependencies, right? So you can install one Node module that depends on a whole bunch of others, and it's going to include their dependencies and actually the version numbers of all those dependencies. Just by doing that, we've got all these different ones, and here's the numbers on that. Okay, and so what this does, this package you don't update this. There's a reason it's called lock, right? You don't update this for any reason, but the usage, it ensures that anyone else working on a project, okay, or when deploying, gets the same set of dependencies, okay. Preventing it, so there's this whole, students do the same thing. It works on my machine. That's very common in development as well. Here's you're a developer. And this happens to everyone. You sit there and develop something. Everything works on your machine. All of a sudden, you commit your code or whatever, and all of a sudden, it doesn't work on anywhere else, right? It works on your machine, but it's not working when it gets deployed for some reason, right? So the whole idea, it works on my machine. Well, this really helps prevent some of that, because these are all the specific. Because sometimes you could, a lot of times with a lot of rudimentary frameworks, other libraries, if you don't include everything correctly, sometimes you could forget to include something, and it's going to work on your machine but not somebody else's, right? So the good thing is, using with this lock file, it ensures that the dependencies can be matched when running it somewhere else. Okay, so that kind of prevents the works on my machine issue. And you don't edit this file. README is an important file actually to use when you're a little more when you're really building a real app. You should have that documented in there. These are just, this is some basic Vite stuff, config file. So I think that that's about all I want to go through on that. Okay, so next here, what I'm going to do is you need to learn, okay, so the index.html includes this main.jx, right? So, and remember the index is the entry point into your application. When your application gets deployed, when your application is in a browser, right? It's basically it's a React app. It all, it might be, the code may get put on the server, but when it actually runs, it's just downloaded to the browser and the browser runs it. The first thing it's going to do is going to run the index.html file, right? So it's going to look for this, right? It's going to load this, and then this main is here. And as you can see, the main is importing from your app.jsx, okay? So that's your main, and this is your app.jx, and we're going to look at that one. And so in here, we've got a little bit more stuff. This is the basic Vite thing. And here, I guess I can just pull that up real quick here. I know you guys have seen this, but we want to do run dev. And so here's the Vite. And obviously, like we were talking about, this is this is a favicon. This was in that root level, in that public folder, right? These were the assets. These are a couple of assets that were in the asset directory, a little closer, not in the exact root. This is in the source directory. Remember the assets. And here's the basic app, right? Okay.